Kyle.
And my name's Kai.
So today we are going to talk about
Boolean logic. We're going to concept map it and hopefully make it a little bit easier to understand.
Indeed.
We've got David on camera here, so let's do this. Well, hi there.
Hi.
What's up?
Well, concept maps of Boolean logic.
What's that?
Well, it is a system.
Of what?
Well, it would be
What are we talking about here?
a system of logical operations.
So we need to add that to whatever this thing is?
Yes.
What is this thing?
This thing is...
A concept map?
Yeah!
Alright, that's
Wow.
cool.
Yeah.
Who designed this whole crazy wackadoo thing?
If my memory serves me correctly, that would be George Boolean.
When?
Well, it was developed by him in the 19th century.
Alright, that tells me somewhat, but what is this even used for? I mean, I don't know anything.
Well,
Yeah.
electronics.
Electronics?
The electronics.
Why?
Because they work off a binary or a true or false statement in order to work.
Wait, so there's no partial in between?
No, a computer does not question itself.
Okay. So it's sort of like that movie I, Robot?
Absolutely. Except without the
Robots.
robots.
Alright, let's keep going.
Alright. So,
What else can we add to this map here right now?
let me think about that. David?
Algebraic?
Yes, it's algebraic.
Alright. Do all electronics use this? Or just ones with like computer chips?
Pretty much all electronics.
Anything with like computer software, hardware?
Anything with hardware uses this. Software uses this.
You can add that.
Examples of computer chips.
Intel makes chips. Okay.
You can tell who our sponsor is. Intel.
No, music gaming. Anyway, let's keep going. What else can we add here? Well, some people don't know what binary is. Well, I don't think it is.
Yeah, hopefully engineers know what binary is. Binary is 1 or 0. It's a system of ones and ones.
1 or 0 to represent true or false statements.
Yeah, we can go with that.
Alright, let's go with that. So now here to present you with an example, like a very basic example, extremely basic, of how Boolean logic works, just to put in everybody's heads, is Kyle, Andrew, Rodgers.
Kyle. So, Boolean logic. Things can be either true or they can be false. They cannot be in between. So, for example, an animal that meows must either be a cat or it can be a dog. Well, obviously, it cannot be a dog because dogs do not meow. But so, it must be a cat. And we'll use a 1 to represent true, and for a dog, we'll use a 0 to represent false. So, cat, true, dog, false. Is there anything, we could use this in
Christian worldview?
Yeah.
Yeah, I have an idea.
Alright, and here to use the Christian worldview edition of Boolean logic is Kai.
Hi. Alright, let's start out with a basic thing that I learned a little while ago. We're going to take two different statements here. As a Christian, one of these can't be true for you, and one of these must be true for you. Alright. So the first statement is God, the creator of the Bible, does exist. That's our first statement there. And the second statement is God, the creator of the Bible, does not exist. For Christians, there's no in between. It's either God exists or God does not exist if you're not a Christian. Alright, so if we were to represent this in binary, a 1 would be right here, 0 would be right here. Now, this 1 in binary is for true. 0 is for false. Now, if you were to think of humans as a programming chip where they only think one or the other, this would apply to human Christians as humans, but if they're programming chips. So, yeah, this is our Christian example for it, just a basic worldview outlook on how a Christian would think. Alright, that's everything we have.
Goodbye.
Goodbye.